Welcome students and viewers. As I have committed in the previous class that for next few days I shall be posting one video of each every day for MCQs for the forthcoming exam NET, which is going to be scheduled to be in initial May. So for few days I will be posting MCQs for at least 10 MCQs daily. Yesterday I had posted, you must have seen this, and today I am again posting this video. And let us start. For the regression model y alpha plus beta x plus u, the estimated line is 20 plus 2x. So alpha is 20 and beta is 2. Beta is 2 and the standard error of the estimate is 0.46. To test h0, beta 0, h1, beta not equal to 0, t statistic is equal to, yes. So here we have to use t statistic. h0 is beta 1 is 0 and h1 is beta 1 is not 0. Every researcher wants that this should be his finding. Beta 1 is not 0, that is beta 1 is significant. For this we use t statistic. Beta 1 minus beta 1 minus beta and divided by standard error of beta. Virtually it is beta cap, beta, standard error of beta. And beta is 2. So 2 by standard error is given by 0.46 and it becomes 0.217. So because this is 0, so 2 minus 0 virtually. So 2 by 0.46, 0.217. So this will be the answer. This is how t statistic is used for testing beta, whether it is 0 or non-zero. Number 2, for the regression equation model, y equals beta 0 plus beta 1 x1 plus beta 2 x2, beta 3 x3 up to beta k xk plus u. Now here the number of independent variables is absolutely k. It has been asked that for test statistic t, the degrees of freedom would be. Now, in any model, when you are going to use t statistic and n is the number of observations which must be less than 30 for using t statistic, and k is the number of variables in the model, then degrees of freedom would be n minus k minus 1. This is degrees of freedom is being taken for testing. So n minus k minus 1, this would be the answer. So for if there are k variables, k independent variables in the model and n is the number of observations, then this would be the degrees of freedom. Number 3, if total cost is this one, marginal cost at q, some value of q must have been given, and I have not noted it down how much the value of q is given, 5. So it is 5. Then simply you just differentiate this total cost function. So marginal cost would be dtc by dx, and this is the total cost, that is 14q rather, it is given in the form of q. So 14q plus 26, and we put the value of q as 5. So 14 into 5 plus 26, this is 70 plus 26 and it is 96. So 96 would be the answer. Simply from this is TC, total cost, you just differentiate once, you will get the marginal cost, and in the marginal cost function you have to put the value of q as 5, we shall get value 96. For the production function, this is CES production function. For this production function, degree of homogeneity is, now we have to find the degree of homogeneity for this production function. So here this is CES production function whose degree of homogeneity happens to be 1. This is linear homogeneous. So Q is A beta k to the power minus A plus alpha L to the power minus A and raised to the power minus 1 by A. Now for finding degree of homogeneity, what we do, lambda k and lambda L, both k and L variables are multiplied by any constant lambda. So A and beta lambda k to the power minus A plus alpha lambda L to the power minus A and raised to the power minus 1 by A. A, and within this big bracket we can take lambda as common. So lambda, then we are left with beta k to the power minus A plus alpha L to the power minus A and raised to the power minus 1 by A. Now this lambda which has been taken inside the common would be lambda to the power minus A, because lambda is raised to the power this minus A, so lambda will have its power minus A. Now this lambda to the power minus A lying inside this whole bracket sign, and this is raised to the power minus 1 by A. So if lambda is taken completely outside, then lambda would be minus A into minus 1 by A and into A beta k to the power minus A plus alpha L to the power minus A minus 1 by A. This A is cancelled, so we have left with lambda, and this is Q. So degree of homogeneity is 1. So this is linear homogeneous, representing constant returns to a scale. Constant returns to a scale. So degree of homogeneity will be absolutely 1, as this is the CES production function. I am showing few more sums. This is fifth sum. Which of the following is a condition of consumer's equilibrium in a two commodity case? In a two commodity case, when we have two goods X and Y, it is PX and PY, and the marginal utility of X is MUX and marginal utility of Y is MUY. This MUX is delta U by delta X and MUY is delta U by delta Y. So consumer's equilibrium is MUX by MUY is PX by PY. Equal to the constant marginal utility of money, that is MUM, or it is lambda. So either or, it could be written as MUX by PX is MUI by PY, or in terms of derivative notations, delta U by delta X by PX is delta U by delta Y by PY. So this happens to be the equilibrium condition in a two commodity case, and here none is just conforming to this one, so answer would be none of these. Question number 6. If the very correlation between X and Y is 0.3 and this in between P and Q correlation happens to be 0.6, then the strength of association between P and Q is higher than X and Y. It appears that the very Karl-Pearson correlation is larger in case of P and Q as it is compared to X and Y. Here it has been asked that the strength of association between P and Q is higher than X and Y. It looks visible that this is, but as far as the strength of association is concerned, for this we shall have to look through R square. Then we can decide how much association in between P and Q is larger. So RXY is 0.3, so R square XY is 0.09. and RPQ is 0.6, so R square PQ is 0.36. Now this 0.09 into 4 becomes 0.36, hence the degree of association between P and Q is 4 times greater than in between X and Y, so this is 4 times. Here we are given the two lists, and we have to match. Box-Jenkins method. This is an econometric technique, and this is used for forecasting. Second is unit root, which is the subject matter of this stationary roots. In time series analysis, we get this. Durbin-Watson statistic, it is used for testing autocorrelation. And Gragner test, it is used for causality between two or more variables. So this is how we can match both of these lists. In this 8th sum, we have the production function, this one, regarding this product, and this is like Cobb-Douglas. So regarding this production function, this has been asked. Decreasing returns to a scale. We have seen in the Cobb-Douglas, I have covered Cobb-Douglas quite in detail, that for decreasing returns to a scale, alpha plus beta must be less than 1. So decreasing returns to a scale is alpha plus beta less than 1. Increasing returns to a scale. Increasing returns to a scale when degree of homogeneity is greater than 1. So this is increasing returns to a scale. Output elasticity with respect to labor. Now in the production function, we have seen that the output elasticity with respect to labor is the power of labor, that is beta, and output elasticity with capital is alpha. So output elasticity with labor, that is beta, so it is beta, and output elasticity with respect to capital, that is alpha. So this is how we measure here. Regarding sampling test, population mean with known variance. Now, this is the concept of sampling. So when we are in the know of the population variance, then we use Z test. So when population variance is known, Z test is used. Population mean with unknown variance. And when the population mean has to be tested and the population variance is unknown, then we just calculate unbiased estimate of the population variance, that is the t distribution. Then we use t distribution. Comparison of variance, this is done with the help of F distribution. And goodness of fit, a very famous test, that is a chi-square test. So this is how. And in sampling, MCQs are most often asked. So if the students, just I am telling to the students, the viewers as well, that if you want that the separate video should be made on the sampling, then you do place your demand and your requirement, and you're making separate video on sampling and all the tests, 4 tests, and MCQs regarding those tests. I'll just explain in the class. So if it is so, then you do ask me in the comments. I will come with another video about all the sampling tests. So for today, let it be. So just I am solving 1-2 questions more. In the 9th question, it has been asked, if sample statistic theta1 is more efficient than theta2, it implies that in statistics, theta1 is efficient than theta2 if variance of theta1 happens to be less than variance of theta2. Smaller the variance, more effective is the relationship, more effective is the variables, more useful are the estimates. So those estimates which have the lesser variance or a smaller variance in comparison to any other estimate of the same model, then the estimate with smaller variance is said to be efficient than those estimates which have the larger variance. So variance of theta1 must be less than variance of theta2. So this would be the answer. Here, regarding sampling, though sampling is a very extensive chapter, and almost in all NET exams, questions are being asked from sampling. So if students and viewers think that we should make a separate video on sampling, then you must ask me in comments. I'll make a separate video on sampling in a quite extensive way. Here we have few items in list 1, few in list 2, we have to match. Simple random sampling. Simple random sampling. This means that while making samples in all the trials, each item will have equal probability of being selected into the sample. So, equal probability of each items in all trials. This is called simple random sampling. Now, random sampling is being said when there is an equal probability of selection in a trial. In one trial, if all the items of the populations are having the same equal probability of being included in the sample, then it is called random sampling. A stratified random sampling, this is in this type of sampling, there is a random choice of all items from each stratum. First of all, the entire population is being separated into different strata, different layers, and then from each layer we choose the sample, and there would be a random choice of all items. So this is third is D, and systematic random sampling. Systematic random sampling is in the sampling method in which there is a random selection of the first item, and thereafter we go for the systematic of the rest. So random selection of the first item, and then there is systematic choice of the rest. It is called systematic, stratified systematic random sampling. So this is what in these 4 questions. And once again, if you think that there should be a separate video on sampling, then I'll make it another video if you do ask me. Final last question, and it is a very deceptive question. The answer lies here, but it looks like a deceptive to the students. Total cost function is given and price is 15. Then it has been asked that find marginal cost of the producer in equilibrium. This is what has been asked in the question. This was asked in previous NET exam. Now, if you just monitor this question a little bit closely, then it appears that this sum relates to perfect competitive market. Perfect competitive market, as because price is fixed for a firm. For a producer, price is fixed. And in a perfectly competitive market, we know that price is equals marginal revenue, and it finally equals marginal cost. If you do remember the diagram, this is 15 and this is marginal cost, it is equilibrium. Now, it has been asked that find marginal cost in equilibrium, and it appears from the diagram that in equilibrium, this marginal cost equals this price. So, marginal cost must be 15 equal to the price. It could be verified that at this point profit is maximized. So, profit, we define profit TR minus TC. TR is P into Q. Is it Q? Yes. P into Q. P is 15. So 15Q minus TC. Minus TC is 2Q square minus 5Q minus 10. 15Q minus 5Q. 10Q minus 2Q square minus 10. This stands as the profit function. Now to maximize profit, first order condition requires that d pi by dq equals 0. This is 10 minus 4q equals 0. So 4q is 10. So q is 10 by 4 and that is 5 by 2. So equilibrium output level for the producer is 5 by 2. Now if you put this Q value 5 by 2 in MC function, we shall get 15. It could be cross-checked. So MC is dTc by dQ, and TC is 2Q square plus 5Q plus 10. So this is 4Q plus 10. Now in this MC function, we must put the value of Q as 5 by 2 equilibrium value, because here it has been asked that find MC in equilibrium. So 4, not 10, it is 5. 4 into 5 by 2 plus 5. This is 10 plus 5 and 15. So MC, and in the equilibrium, the marginal cost of the producer would be 15. So this can be cross-checked by this way also. Otherwise, this equilibrium condition states that in equilibrium condition, price equals marginal cost. So price was 15, so marginal cost was supposed to be 15, and this has come out. So this is all for today. 10-11 sums I have solved it. Tomorrow again I will come with few more sums. But for today this is all. Once again to the students, if anywhere they find any problem in economics, straight away ask me with comments, with your requirements. I will come with the answer with separate videos wherever and anywhere and everywhere. If you have any problem, do ask me. I'll just comply with your comments and queries. But for today, this is all for today. Best of luck to the students. Thanks.